Welcome to this polymer reaction engineering aspect. Here today we are going to discuss the gradient in graft copolymer, polymers and its composition, isomerization in the polymeric system. Now here one thing is important, that before we go into the either designing of any kind of a polymeric reactor or any kind of designing of a polymeric system, then the knowledge about these kind of a copolymeric system, composition, isomerization is extremely essential. So in this particular chapter or in this particular lecture, we are going to deal this kind of a approach, so that we can be aware that how the polymer structure being changed in due course of time. Now, before we go into the detail of this particular approach, let us have a brief look at what we studied earlier. We studied about the short history of the polymerization process, monomer and its distribution, especially in respect to the homopolymer, copolymer, statistical and random alternative block copolymer, etc. Now, to enhance our knowledge about these kind of a polymeric system, in this particular segment we are going to study about the gradient in a graft copolymers. Apart from this, we will discuss about the polymers and its composition, especially with respect to the molecular weight distribution. And in the previous lectures, if you recall, that we discussed that the polymers may have a different type of a chain, may have a different type of random distribution of a chain, etc. So, this type of approach affects the molecular weight of the polymeric system, and precisely we can't predict, because of the presence of a various discreted polymeric chains in the system, we can't predict the precise molecular weight of polymeric system. So, we will discuss about that how we can analyze, because the knowledge of this polymeric system molecular weight is quite essential. So, in that case, we should know that how these molecular weight of polymer are distributed alongside of this polymeric mass. Then we will discuss about the isomerization process in the polymers. So, let us have a look about several other aspects of polymers, especially with respect to the distribution of monomers. The first category in this class is the gradient copolymer. Now, as the name implies, that they are the novel class of polymers that exhibits the gradual change in composition, as you can see in this particular figure. Now, here you see that initially, now you can see in this particular figure, where you can imagine the scenario that this is the block copolymer type of a system, and here there are two monomers, monomer A and monomer B. And if you see in this particular approach, the monomer A is just shifting towards the right hand side, and monomer B is occupying its place, and simultaneously there is a gradual change in the system with respect to the entry of monomer B into the system. So, you can see that here we are having a different class of a polymer, and that is called the gradient effect with respect to the copolymer system. Now, in other words, if you wish to represent that, it can be represented as triple X, like Y, X, Y, X, X, Y, Y, and so on. So, by this way, it gives you enough opportunity with respect to the development of a new product, development of in situ polymerization process, and sometimes you wish to introduce another component within the system. It gives you enough opportunity for that particular approach too. So, they are usually in other words, you can say the gradient polymers, they are formed by the polymer chain whose compositions are gradually changed alongside of the backbone of the structure. Now, this arrangement, if you see, that is different from random copolymeric system, which maintains at a constant average composition along the side of the chain, and the block polymer, which change abruptly once purely A monomer to purely B monomer. Now, here you can see that the difference among all three kind of copolymeric system. Here, this is the block copolymer. You can see there is a blocks of two monomers. Now here you can see this is the random copolymeric system. Here there are two monomers, maybe A and this one is B. Now you can see their random distribution along the side of the backbone. But here you see that there is a gradual change, or this is referred as the gradient copolymers. So this particular figure gives you enough opportunity to understand the concept of a gradient copolymer system. Another approach is the graft copolymer. Usually this graft copolymer consists of a molecule with one or more blocks connected to a backbone as its side chain. It is just like that. This is the backbone of polymeric system, and you are grafting one polymer along the side of its backbone. So it's having the constitutional and configurational characteristics that distinguish them from the main. Now, a branched copolymer with one or more side chains of a homopolymer you can attach to the backbone to the main chain. Now, just I am giving another approach about this grafting. It is just like that. You are having this polymer chain and you are just introducing another polymer. This polymer may be consist of several monomeric units, and you are introducing this one. So by this way you are implanting another polymer, or maybe the same type of a polymer, that depends on the scenario. And these chains along the side of this backbone may have a liberty to grow on its own. So this is you can say this offers a very good opportunity to develop a new polymeric product, specialty polymers, etc. So this thing should be in our mind. Now these type of graft copolymeric system can be used as impact resistant materials. They are also useful for the various kind of a thermoplastic elastomer, compatibilizers or emulsifier to create the stable blends or alloy. Now the reason for this kind of a various approaches is that ultimately we wish to have a polymer system or a polymer, those who are having the desired property. Maybe if you recall the first lecture where we discussed that it should have a flexibility, it should have impact resistance. So right from the flexible polymeric film to the automotive bumpers, etc. So we are having a discrete type of a product profile. For every discrete type of a product profile, we must have a different polymeric system. So that's why we are discussing all these kind of a system. Now thus what kind of a copolymer with the help of a grafting may have a more thermostable than other homopolymers, etc. So this type of things are you can say that tailor made. Now when we talk about the different type of graft copolymers, so usually there are three different type of graft copolymeric system. One is the graft onto, another one is the grafting from, and another third one is the grafting through, which are used for the grafting of the copolymers. So this is the three broad spectrum. Remember, everywhere these distribution or these type of a classification, it all depends on the desire, what kind of the product profile we require, as well as depends on the various operation and process conditions as per the need of this particular product profile. So let us have discussion about the different classes of grafting copolymer. The first one in this category, that is the grafting onto. Now usually it involves the functional group, let us say that X in the backbone of the polymeric system or the polymeric chain, which are distributed randomly and sometimes coupled with any kind of a reactive group, say let us say Y. Now at the end of this this branch chain. Now this coupling reaction are possible only when there is a chemical modification of the backbone, that is the grafting carried out in the presence of any kind of a homogeneous solvent. Now remember, one thing is essential in this juncture, that the presence of a reactive group. Now just let us see that how we are performing this type of a grafting onto. Now here see, this is your polymeric backbone. I am not putting it in a straight manner. Now here the X is the monomer. Now you are performing the polymerization reaction with the help of another monomer, that is called the Y, and it represents like this. And sometimes it may represent like this. So this is the basic approach of grafting onto. Now another form that is called the grafting through. Now this is the polymerization system of a lower molecular weight macromer with at least one end having the unsaturation. Obviously, unsaturation is required for the growing of polymeric chain, because if you recall the first two lecture where we discussed that there must be certain active sites or reactive site so that the chain of the polymer system can grow along the side. So at least one end should have any kind of unsaturation with the growing polymer chain, results in the grafting. Now there is a linkage between the individual molecules. If the growing molecule reacts with the two or more unsaturated sites in different backbone, results in, sometimes it may result the cross-link structure, sometimes it may refer as any other kind of a branch structure, and so and so on. So let's have a look about this particular approach. Now this is the grafting through. I am just giving you the pictorial thing. Now let us have one monomer, maybe any kind of a monomer. Now this is, now for as I discussed previously, that for any kind of polymerization reaction, usually there are three steps: initiation, propagation and termination. So sometimes if you cannot initiate the reaction in the suo moto, then you require certain initiators, and these initiators are very case sensitive. We will discuss this approach later on. Or sometimes you may require any kind of a catalyst. So this can be grafted like this. Sorry. Like this. So this is the grafting through type of approach. Now another the last type of the grafting copolymer approach is called the grafting from. Now the polymer, usually those who are having the active site, they are used in this particular process to initiate the polymerization of second monomer. Usually just to make the things bit easy, that the polymers sometimes they are having the active sites, so that they can initiate the things on its own. Sometimes they may have certain other things need to be incorporated during the things, like in the previous slide we introduced another initiator, etc. So in this approach, the grafting from, that the polymer with active site, those who are having sometimes active sites, maybe their functional group, maybe the unsaturation, and maybe double bond, triple bond, etc. They can be utilized, this particular sites can be utilized to initiate the polymerization of second monomer, not the first one. So this depends on the nature of the site created on the backbone. Sometimes may be anionic, sometimes free radical, and as we discussed in the previous lecture about the Ziegler-Natta type of. So usually there is a graft created on the already prepared. This is the backbone. Now there is a graft created on the already prepared backbone in the second polymerization step. Now usually this particular approach is very beneficial as far as the industrial applications are in question, but there are certain disadvantages associated with this particular approach, because sometimes it is not possible to predict the molecular structure and a number of graft form. and thereby in situ they you will not be in a position to predict the either weight average molecular weight or a number of average molecular weight, and these are, you can say, the fundamental property of any kind of a polymers. But you can say precise knowledge about those kind of a free radical, those kind of active sites, etc., may give you enough success by the designing the polymeric system. Let us have a look about this grafting through. This is you can say the things where you are having the active sites and another monomer through which you would like to graft on it. You may have like this. Right, this is the polymer backbone with active sites. You see that there are certain active sites, and here is the monomer. Probably this monomer may not have active sites. So, you are utilizing these active sites to get this monomer attached over here, and you see that here this particular thing is attached. So, this is you can say this is a very beautiful approach for the development of a new kind of a product or to the improvisation of other kind of product. Now, next is that we would like to have a discussion about the polymer and its composition. Now, it's a, you can say it's a very integral part of our polymer reaction engineering, because you know that different type of a polymeric systems we have already discussed, different type of a polymers we have already discussed. Now, how to achieve those desires? This is a big question. Like in the previous slides, we have discussed that we are having the grafting on it, though we know that this is the principle, but how to achieve, how to go ahead with the polymerization process, that is the main important thing. Moreover, because as previously we have discussed that whenever we start the polymerization process, then it is a chain driven process. So, sometimes if you keep on going all these kind of polymerization process, your polymer mass will become bulky, and in that case you will not be able to control the molecular weight. And once you are not being able to control the molecular weight, then it is a very difficult thing, because you will not achieve the desired result as you require for different type of applications. So, keeping this thing in mind, the Carruthers etc., they divided the polymer into polymerization process into different segments like condensation and addition. They are based on the compositional disparity between the polymer and the monomer which they were trying to synthesize. So, whenever we discuss about the polymerization process, for the ease of our business, we classify the things into different categories. And do not be confused about the polymerization process and the polymers. Earlier we discussed about the different type of a polymer, different type of a classification, etc. But here we are discussing about the polymerization process, just to go ahead with the reaction engineering concept. So, people have divided in, this polymerization process into various categories which we are going to discuss. The more generalized categories are listed, that is step growth or a condensation polymerization, and a chain growth or addition polymerization. So, the classification based on condensation and addition relies on the polymer composition or structure. What kind of composition do you have, what kind of the structure, maybe the network structure, maybe the linear structure, etc. Now, this the classification based on step growth or chain growth polymerization, it relies on the mechanism. What kind of the mechanism is there? Maybe the free radical mechanism, maybe the other mechanism, etc. So, based on the process, based on the requirement, this polymerization process can be classified into these two broad spectrums. Now, these terms you can say can often be used for various kind of synonymous, because most condensation polymers they are produced through step growth polymerization, and most of the addition polymers they are produced through the chain growth polymerization. So, that is why if you again come back to the previous slide, there are two broad spectrum: step growth, chain growth polymerization, and condensation and addition polymerization. So, the polymer or polymeric molecule formed by both type of polymerization may have the same structural identity, which are repeating itself into the structure. Now, usually these repeating units are said to be the monomeric unit, as we discussed in the previous lectures. The number of monomeric units they are attached, they decide the size, that is the molecular weight, which we are discussing, that number, average, weight, average, etc., the molecular weight of the polymer, and which is usually sometimes these are called the degree of polymerization. So, let us have a look about the condensation and polymerization. Usually it is a common phenomena, and we will discuss about the step growth and chain growth later on. So, the condensation polymerization process, it deals with the polyfunctional monomers. They react with the different condensation reaction, and with the removal of some of the small molecules, maybe the byproduct, etc., like water, HCl, NaCl, etc. So, you need to continuously remove these byproducts from the reaction stream. Now, these type of a reaction you can perform either in a bulk or as an interfacial polymerization, and these reaction requires regular removal of byproduct, that is essential, which may be sometimes volatile in nature and sometimes very sensitive with respect to the thermodynamic approach or thermodynamic equilibrium. So, these type of things you need to take care of while dealing this kind of a condensation polymerization. Now, depending on the type of a monomer, because monomer plays a very vital role while deciding the structure of any kind of a polymer. So, usually the class of monomer used for the polymerization or the polycondensation product sometimes may be linear or non-linear, maybe the branched, maybe the cross-linked, etc. Some of the naturally occurring polymers like cellulose, cotton, silk, wool, they are the condensation polymers, as removal of water take place during the synthesis from some hypothetical reactants, because these are the natural one, that is why we are using the word hypothetical. So, the condensation polymers have been classified as a polymer whose repeating units are combined by the functional unit of one kind or another, such as ester, amide, urethane, sulfide, ether, etc. So, again I am repeating the things that you require at least one functional group to carry out the polymerization reaction. Now, the structure or this particular condensation polymerization steps, they are defined as like this. Now, X represents aliphatic or aromatic groups, and Y represents functional groups, maybe functional group may be like SO2 or OCO, NHCO, etc. So, you can see that easily that these functional group, they play a very vital role for carry out this kind of condensation polymerization step. Now, another example, because that was a theoretical example, the best example in this category of condensation polymerization is nylon 6,6. Now, which is produced from polycondensation reaction between the hexamethyldiamine and adipic acid. You can see here in the figure that this is the adipic acid combined with the hexamethylene diamine to form this nylon 66. Sometimes people refer as nylon 66, it is not the correct one, it is nylon 66, which is very. Now, in other words, if you wish, then we can give the clear picture. Now, here I am giving you the adipic acid which combines with how this combination takes place. Now, this is adipic acid. Now, this particular juncture combined, and this is N-hexa diamine. Now, both of them, they combine together and 2NH2O, that is the removal of water molecule, that is essential as we discussed in the previous one. Then they form the nylon 66. Now, this is now you can see now this is the amide group, and this is the structure of nylon 6. So, this is one example which we discussed in the previous one. Now, another example, that is the formation of the polyester or polyethylene terephthalate. This is again a very useful product with respect to the day-to-day affair, like PET bottles may be used for the drinking water, packaging of other things. So, it is again the useful product of the condensation polymerization. Now, usually it is carried out with the help of a reaction between N-ethylene glycol and N-terephthalic acid. Now, have a look about this one. Now, this is your ethylene glycol, this is the terephthalic acid, now you see that there are enough opportunity available for polymerization. There are so many active sites available to this particular segment. Now, here there is a formation of now this is the byproduct which you need to remove continuously. Now, this is called the polyester or polyethylene terephthalate. So, this is I can say a very useful product, and it is contributing a lot to our day-to-day affair or day-to-day life. So, at this juncture we are just aware about this one. Now, here you can see another type of another type of thing which is quite interesting, and that is the example of a nylon 6 produced from intermolecular condensation of a caprolactam, polycarbonate or polyethylene pyro mellatimate. Now here this particular reaction is again very important because this is a ring opening polymerization. So we have discussed about this the formation of nylon 6,6 and PET etc. in this particular segment with the help of knowledge about the condensation polymerization. In the next lecture, we will discuss about the addition polymerization, which is again provides enough opportunity for the production of a various useful product in our day-to-day affair. Thank you very much.